25 to 40% of patients in developing countries develop surgical site infections. This is partly due to the high cost and therefore lack of sterilization methods for surgical instruments. Another issue in these regions is the lack of clear water, which can cause problems such as intestinal worms and arsenic poisoning. Because of the inconsistency in electricity sources in some areas of developing countries, there is a need for this project to be fully dependent on a renewable energy source. The idea was to design a device that would have a dual purpose as both a distillation and a sterilization unit. The project uses a parabolic mirror to concentrate solar energy on a pressure cooker attached to the frame by a suspension system. We would be able to rotate and pitch the mirror based on the position of the sun, and sterilization mode should reach and maintain the minimum condition of 120 Celsius and 15 psi for at least 20 minutes. The mirror frame includes a tilting mechanism. The autoclave is a pressure cooker attached to the frame with an eye hook and a suspension system right above the mirror. The frame can tilt up and is held in this position by supporting legs. It's also able to swivel with a lazy Suzanne attachment at the base. The autoclave pressure cooker has a pressure gauge attached to its pressure valve. During distillation, steam will flow from the pressure valve to the condensation unit, which contains a copper coil and a bucket full of water to condense the steam. The base of the mirror is made of laser cut fins that are attached together. It's then coated with poster board and a emaille sheet to make a reflective mirror surface. This surface is able to concentrate light from the sun that's then directed at the autoclave to boil water. During small-scale testing, sterilization conditions were reached after approximately 30 minutes and were maintained for an additional 20 minutes. In 40 minutes, about 150 milliliters of distilled water were collected. Although the device appears to be effective in completing a sterilization cycle in approximately an hour while maintaining a low cost, future work would include cell culture testing, comparing bacterial influence in the obtained distilled water